Most students think that the dot product is just about multiplying components together, but that's actually the least interesting thing that it does, because the dot product isn't really about numbers, it's about geometric meaning. And so today, I'm going to show you the real and intuitive purpose behind what the dot product really is. And once you see it, I promise that physics is going to become way more powerful and way more intuitive. And that's exactly the kind of clarity that this channel is built for. So let's get started. I want you to watch closely with what I'm about to write. A dot B is equal to the magnitude of A times the magnitude of B, cosine of theta. Now, what I've written here holds the key to the true power of the dot product. And I want you to appreciate that the dot product just collapsed 3D vectors into one single number. This number is what captures something deeply meaningful about the relationship between these two vectors. It's not just about arithmetic, it's about geometry and alignment. So let me show you what I mean. So here are two vectors, A and B. Now, this part here is B cosine theta. And we like to call this the projection of B onto A. So when you think about it, the dot product A dot B is just the magnitude of A times the projection of B onto A. In essence, the dot product is just telling us how much of vector B is pointing in the direction of vector A. And that's the real magic of it. But believe it or not, we can actually take this a couple of levels deeper. And this next part are where things are going to get really interesting. Now here's the insight that most students actually miss. The sign of the dot product is controlled entirely by the term cosine theta. It's not controlled by the magnitude of A, because that's always positive, and it's not controlled by the magnitude of B, because that's always positive. It's purely controlled by this theta. This means that the dot product is secretly just measuring alignment. So let's break that down. So let's cover three scenarios. A dot B being less than 0, greater than 0, and equal to 0. And what I've drawn here at the bottom are three unit circles, and I've labeled the 90 degrees and 270 degrees angles respectively. So let's get started. The dot product is less than 0 when theta is greater than 90 degrees, but less than 270 degrees. And on the unit circle, here is what that looks like. And the dot product is greater than 0 when theta is less than 90 degrees, but greater than negative 90 degrees. And on the unit circle, it looks like this. And the dot product is equal to 0 when theta is equal to 90 degrees. And on the unit circle, it would be this point right here, or this point right there. But we can actually take this so much further still. So what we basically just discovered is that when the dot product is negative, the angle between the vectors is obtuse. When it's positive, the angle is acute. And when it's 0, the vectors are just perpendicular to each other. So let's see what this looks like. Number 1, the angle is obtuse. And now the projection of B onto A is actually in the opposite direction of A. This tells us something incredibly valuable, and that is that the two vectors are misaligned. And the greater that this angle theta is, the greater the misalignment. Now, if the dot product is greater than 0, the angle is acute. And now the projection of B onto A is actually aligned to A. And the closer that these vectors are to each other, the greater that the alignment between that projection is. For our third scenario here, the angle between them is 90 degrees, meaning that the two vectors are perpendicular to one another and there is 0 alignment. This means that the vectors aren't helping each other in any way, but they're also not fighting against each other. They're actually just ignoring each other. Now, I want to take some time to really make it clear why this is so powerful. Number 1, you can instantly recognize if two vectors are aligned now without having to do any calculations. Number 2, you can instantly tell if two vectors are working against each other now, aka they're misaligned, without having to do any calculations. And lastly, you can instantly tell if two vectors are just completely independent of each other, again, without having to do any arithmetic. Now, this is going to become incredibly empowering when you start to learn about work, power, electric fields, and force decomposition later on in your physics career. The dot product is pretty much everywhere throughout physics, and now that you understand what it's actually measuring, this insight is going to put you ahead of the curve. And if you can only remember one thing from this video, I want you to take away that the dot product is simply the measurement of how aligned two vectors are. So if this video helped boost your intuition or something clicked, I'd like you to consider just sharing what you learned in the comments down below, because you sharing your expertise can be the one thing that someone else needs to finally understand this subject. And that's what this channel is all about. Us just sharing what we know so that we as a collective can be better.